In this video, let's take a look at how exponential functions are formed. Suppose you were given $10 and told that each day you show up to class, the amount you're given doubles. What? What kind of school is this? I want to go there. Okay, number of days you go to class. So on the 0th day, you get $10. You pay $10. On the first day, it doubles. So we multiply that by 2, we get $20. On the second day, multiply by 2, $40. And then you can just imagine, now we're going to get $80, $160, 160 times 2, $320, $640, 640 times 2, $1,280, and finally $2,560. Okay, so we're always multiplying by 2 basically. If we're always multiplying by 2, let's see here. As the value of the independent variable, the days, increases by 1, what is happening to the value of the dependent variable? I think we see that. It's increasing by a factor of 2. Create a formula that models this situation. Well, we always have to start off with that 10. That's our base number, right? So 10. And then what we do from there is you multiply by 2, multiply by 2, multiply by 2. How do you show repeated multiplication? Well, that's just with exponents. 2 to the power of something, let's call it x. And that's going to equal our equation, our y. Y is equal to 10 times 2 to the power of x, where x represents, let me rewrite that, where x represents the number of days you go to class, and the y value represents the amount of money you get paid. Money you get paid. Okay. All right, so let's take a look at the basic form of what we call the exponential function. An exponential function is a function of the form c times a to the power of x. You can see the c was representing the 10, the a was the 2, and the x was the x. Where a is a positive real number greater than 0, and a can also not equal 1. You cannot have a 1 in there. Otherwise, you're basically saying 1 times 1 times 1. You're doing repeated multiplication of 1, and that doesn't grow exponentially. It doesn't do anything for you. And c is also a number not equal to 0. Otherwise, you would just get a value of 0 for the y value every single time. And again, it would not be growing exponentially. Okay? The domain of f is, keep in mind, since it's talking about the x values, it turns out that x can be all real numbers. Okay, so we can say all real numbers. The base a is what we call the multiplying factor. And because f of 0 equals c times a to the 0 power, which is technically just c, c is called our constant. Or you can also call it the initial value. C is also the initial value. All right, let's take a look at the next page. So taking a little bit, looking a little bit closer at our function, which is f of x equals c a to the power of x. A is greater than 1, and a cannot equal 1. Now, if I take a look at this composite function, f of x plus 1, keep in mind that f of x plus 1 is thinking of f of x as c times a to the power of x, where x is now becoming x plus 1, like that. And then this is, you can see here, is divided by f of x. What's f of x? Well, f of x is just c a, and then it's just x, so it's c a to the power of x. In this problem here, you can see that c's are the same on top and bottom, so those cancel out. But if you take a look at your property of exponents, what you have is a to the power of x plus 1 divided by a to the power of x, what can you do with that? Well, based on the laws of exponents, a to the x plus 1 divided by a to the x is the same thing as minus x altogether as one exponent. And the x's cancel out. And what we're left with then is just a to the first, or just a. So this basically means that you just get a there. Okay. Or another way of writing this is if we just want the f of x plus 1, then what we can do is bring that f of x over. So f of x plus 1 is the same as a times f of x. Okay. All right. That'll conclude our basic idea of what exponential functions look like.